Okay, so no discussion about fault tolerance or about redundancy would really be complete without a discussion about RAID. Now, RAID stands for Redundant Array of Independent Disks or Inexpensive Disks. Just really depends on where you read. RAID is a fault-tolerant array of disks. Now, there is one method of RAID that's not fault-tolerant. We'll cover that in just a moment. But for the purposes of our discussion, it is a redundant and a fault-tolerant setup. Right? So data can either be mirrored in the case here of RAID 1, or it can be spread across multiple disks, and we'll talk about that in just a moment. So let's take a look here. First off, we have RAID 0, and that's disk striping, period. There is no parity, and it's not fault tolerant. Okay, so that's why I have that highlighted in red. You need to understand that RAID 0, yes, it gives you a speed boost because we're writing to multiple disks versus trying to write an entire file to a single disk kind of sequentially. We're writing to multiple disks at the same time or near the same time. Okay, so it gives us an increase in speed. However, if we lose one of those disks, we lose all the data. There's no fault tolerance. RAID 1 is disk mirroring. Okay, so if you look back in this previous example, we have RAID 1 here. We basically have two different drives, and we have data copied between both of those disks. All right, so block 1, 2, 3, and 4 is written to drive 1. Block 1, 2, 3, and 4 is also written to drive 2. So in that case, if we lose one drive, we still have a copy. We can basically break the mirror and make the mirror now the primary. All right, so in RAID 5, what we're doing is we're writing what's called parity. And so that disk striping with parity means that we're going to take a piece of data. Let's just say, for instance, we have 64K chunks of data, and we have, let's say, 192K of data, or in this case, let's make it 4 actually to make it easy. So we have 4 chunks of data. We have 5 disks, 4 chunks of data, 64K per. So that gives us basically 256K that we need to write. So we're going to stripe that 64K across disk 1, disk 2, disk 3, and disk 4. Hence, we see A1, A2, A3, and A4. Now on disk 5, we're going to run some type of mathematical algorithm against those 4 pieces of data, A1, 2, 3, and 4, and we're going to come up with a parity result. Okay, so that result is then written to disk as AP. Because we have A1, 2, 3, and 4, AP would be the parity, basically the parity stripe. So if we lost, let's say disk 1, and we lost A1, we could take A2, 3, and 4, and extrapolate that out, compare it against parity, and say, okay, well, we know what parity is, we know what 2, 3, and 4 is, so we know what A must be, or A1 rather must be, and we can recreate that data. Conversely, if we lost disk 5 in this example, well, we have the original data, A1, 2, 3, and 4, we can just recreate the parity information. So the key takeaway here is we never write the stripes of data and the parity to the same disk. We always make sure parity is on a different disk. So that way, if we lose a disk, we can rebuild. We either have the original data or we have some of the data plus parity. So you can see in B2, we have B1, 2, 3, then we write parity on disk 4, and then we have stripe 4. For C, we have C1 and 2, then we write parity on disk 3, then we have C3 and C4. And you can see how it goes on and on. So we never write the data and the parity to the same disk. Now there's another type of RAID that we need to be aware of, and that is called RAID 6. RAID 6 is very much like RAID 5 in that it's striping with parity. In RAID 6, we can actually lose 2 drives and still be able to recreate that data. Okay, so RAID 6 gives us an additional level of redundancy. And then just for your information, I have RAID 10 listed as well, and that is disk striping that is mirrored. So we're going to stripe data across our disks and then mirror that set of disks to another set of disks. So that gives us the kind of the best of both worlds. It gives us the speed increase of disk striping and also the fault tolerance of mirroring.